Hello everyone. Okay, so we will start the new chapter today, waves. New chapter, we'll start waves now. So what do you mean by a wave? Wave is the one which carries energy. Wave is the one which carries energy, of course, due to some disturbances. So a wave is a form of disturbance. See, if the water is plain and on a lake, if the water level is plain and without any disturbance, as you throw a stone, what will be created? The waves, disturbances around it will be created, no? So they come to the shore, those disturbances are called waves. So, what do you mean by a wave? Write down, wave is a form of a disturbance. Wave is a form of a disturbance which propagates from one region of form of disturbance, which propagates means moves, propagates from one region of space to another, one region of space to another. So that is wave motion, that is called a wave. Wave is a form of disturbance. So there are mainly two types of waves. There are two types. One is called mechanical waves. Another is obviously then non-mechanical waves. Non-mechanical waves. Mechanical waves and non-mechanical waves. Okay? So there are two types of waves. Waves are already gottide. Disturbance created. Even when a string is connected to a rigid support, and from here if you pass on the disturbances, this is how the string is going to move. That is how the string is also going to move. Correct? No? Is that clear? That is how the string is also going to move. So, a string is also a disturbance. In the string those disturbances are moving. So it forms the wave. So it carries energy also. Those disturbances carry energy from one region to another. Then there are two types of mechanical waves. The two types of waves, mainly, they are called mechanical waves and non-mechanical waves. Okay. So mechanical waves are the one which require material medium for their propagation. So write down, mechanical waves are the one which require material medium for their propagation. Material medium for their propagation. Example, water waves. When water, if there is a water, on the pond at the same level, as you throw the stone, you are disturbing it, those energy will be carried through. Correct? Next, sound wave is another example. As I speak, the pressure will be different in different regions. As the words come out, it will create a region of lower pressure immediately out of my mouth. Then the next region will be compressed one. Other region will be again having low pressure. So there will be rarefaction, compression, rarefaction, compression. So such waves are sound waves are also require material medium for their travel. Seismic waves, bhookampa earth waves, bhookampa earthquakes, they require earth as a medium through which they can travel. So water waves, sound waves and seismic waves. Is that clear? Clear? So example, they are mechanical waves are the one which require material medium for their propagation. Water waves, sound waves and seismic waves. Next, non-mechanical waves. Non-mechanical waves. These are the waves obviously which do not require any material medium for their propagation. So you can write it now. Are the waves which, is it visible if I write it here? Which obviously do not require any material medium for their propagation. Example, light, ultraviolet rays, all electromagnetic waves. EM waves are electromagnetic waves. So all these electromagnetic waves, they can travel in vacuum. These non-mechanical waves can travel in vacuum also. Whereas non-mechanical waves, they cannot travel in free space or vacuum. They cannot travel in vacuum. Mechanical waves. These non-mechanical waves, electromagnetic waves, they can also travel in vacuum. They can travel in vacuum also. Is that clear? They can travel in vacuum also. So this is a broader sense of classification of mechanical and non-mechanical waves. Next, depending on the mode of propagation, they are again can be classified. Mechanical waves can be classified further depending on the wave propagation direction as two waves, transverse waves and longitudinal waves. So, I hope it is clear to all of you. Okay, so write down. Mechanical waves can be further classified into transverse wave, transverse wave and longitudinal waves. Longitudinal waves. So what do you mean by transverse wave? Transverse wave is the one where the direction of propagation of the wave is perpendicular to the direction of oscillation. So in transverse waves, if the vibrations are in one particular direction, the direction of propagation will be perpendicular to the vibrations or the disturbances. If the disturbances are taking place along XZ direction, then the propagation is, YZ direction, the propagation is taking place along XZ direction. So write down, transverse wave is the wave, transverse wave is the wave in which the particles of the medium, oscillate about their mean position, perpendicular to the direction of propagation of the wave. So if the wave is in this direction, if it is going like this is called one wave, okay? Then the second cycle starts here. If you see, the vibrations will be like this in this plane, whereas direction of propagation will be perpendicular to that. So such a wave we call it as transverse wave. The best example is wave along a stretched string. Wave along a stretched string. Okay. So, if the wave, see here, if the string is connected to one side and it is plane, then this is regarded as a mean position. We call this as a mean position. As it starts to produce vibrations, this is how it is going to transfer slightly, correct? As the vibrations start, the vibrations are up and down, whereas the propagation is along x-axis. So the vibrations of the particles is perpendicular to the direction of propagation. That is why such a wave is called transverse wave. So wave along a stretched string is a best example for that case. Is that clear? For that case. So propagation along a stretched string it is. So now talking more about the transverse wave. Any doubts till now? Any doubts? will consider one wave now. As you are all aware, we consider one wave, two waves, bigger ones. Okay, now two waves are there. One wave completes its motion here, correct? So, this point, uppermost is called crest, the lowermost point of the vibration is called trough. So, distance between two consecutive trough or crest, trough or crest, it is called wavelength. Also, the maximum displacement of the vibrating particle is called amplitude. This is called amplitude A. This is called amplitude A. Following? Okay. So, now this is amplitude. So, there are some key terms to be learned. Key terms. One is amplitude. When a wave propagates in a medium, propagates in a medium, the maximum displacement of a particle, from its mean position, is called amplitude. Of the wave. Is called amplitude of the wave. Okay? Is called amplitude of the wave. Clear? Okay. So ಇದನ್ನು ನಾವು amplitude ಅಂತ ಹೇಳ್ತಾರೆ. I told you no, in a tensor string, if this is a initial mean position, as you disturb it, it forms a wave, no? So the maximum displacement with respect to the mean position is called amplitude, usually determined by capital A. Okay, it is indicated usually by capital A. Next, we'll have to study about what? It's wavelength. Before that, we'll study about its wave period or time period of the wave. Second one is time period of the wave, capital T. Time period, capital T of the wave is the time it takes to complete one wave. Correct? No? Time it takes to come back to its mean position after having amplitude or vibration in one direction and maximum vibration in the other direction, or it is wave time period of the wave is the time taken to set up one complete wave in the medium. Time taken to set up one complete wave in the medium, or it is also the time after which the cycle repeats itself. Time taken to set up one wave, or time taken to continue the cycles of the wave. So time period is the time taken to set one complete wave in the medium. Frequency. Next we will go to frequency. So if the time period is capital T, see here, if it is time 0, then this is time period. One complete wave is set up in the medium. This is another second wave time period. So it will be 2T. I hope it is clear to all of you. Okay. Next, frequency. It is number of waves. Number of waves that are set up in the medium. Number of waves that are set up in the medium in 1 second. In 1 second. Number of waves that are set up in the medium in 1 second. So frequency is denoted by nu or f. Nu or f ಅಂತ ಬರೀತೇವೆ ನಾವು. Okay, so ಏನಾಗುತ್ತೆ, time taken to set up one complete wave in the medium is time period. Number of waves that are set up in the medium in 1 second is frequency. So the relation between frequency and time period is always nu is equal to 1 by t. So SI unit of frequency is per second or hertz. Here it is time period is in seconds. Okay, so time period is in seconds. Unit of this is hertz. Unit of frequency is hertz. Okay, so obviously frequency is inverse to that of time period. Inverse to that of time period. So next key term which we are going to learn is phase of a particle. Phase of a particle. Any doubts? Phase of a particle is nothing but its state of vibration or its state of vibration. Phase of a particle is the state of vibration. State of vibration. Phase of a particle is the state of vibration at any given instant. At any given instant of time. At any given instant of time. So phase of a particle is the state of vibration at any given instant of time. So that is called phase of a particle. That is called phase of a particle. Next one is wavelength. Next one is wavelength, lambda. So wavelength is lambda. That is in previous classes, in the lower classes you might have studied the distance between two consecutive troughs or distance between two consecutive troughs is called wavelength. Also here you can learn a new definition. See, at crust the vibration particles are of same phase, correct? This is where the highest vibrations is seen. For a medium, for a object vibrating about its own localized point, the energies are transferred, of course. Particles are not transferred, no. So this is where they are both are vibrating in the same phase. They both are vibrating in the same phase. So they are vibrating in the same phase. They are vibrating in the same phase. So the distance between the 2 points which are vibrating in the same phase, the distance between the 2 consecutive points which are having the same state of vibration or which are vibrating in the same phase is called wavelength. High school alli ನೀವು ಕಲಿತಿರಬಹುದು, distance between 2 consecutive troughs or 2 consecutive crests is called wavelength. ಅದೇ ಡೆಫಿನಿಷನ್, ಅದೇ ಇದು ಸಹ. ಆದ್ರೆ ಎಂತ ಹೇಳ್ತೇವೆ crust, 2 consecutive crusts are vibrating in the same mode. That is why they are vibrating in the same phase ಅಂತ ಹೇಳ್ತೇವೆ. 2 troughs are vibrating in the same mode. So they are the points which are vibrating in the same phase ಅಂತ ಹೇಳ್ತೇವೆ. So that can be a new definition which you can learn. Okay, wavelength is the distance. Wavelength is the distance between 2 consecutive particles in a medium having athwa which are vibrating in same phase, which are vibrating in same phase, which are vibrating in same phase. Clear? Which are vibrating in same phase. So it is called wavelength. Next, we will also learn about wave velocity. That is given by V. Wave velocity is the distance traveled by a wave in 1 second. Distance traveled by a wave in 1 second. Distance traveled by a wave in 1 second. So idenagutte V is equal to distance traveled is by a wave lambda. Distance traveled by one wave. Nodi illi sa at the starting position and at the position t, when it completes one time period also, they are vibrating in same phase, no? So it can also be the wavelength, correct? So distance traveled by a wave means a single wave is in 1 second, means it's a time. Total wavelength by total time. That can be written as lambda into 1 by t. That implies V is equal to lambda nu is the expression for a velocity of a wave. I hope it is clear to all of you. Any doubts? Velocity of a wave can be given by that. So please try to learn all these key terms. Okay, amplitude, time period, frequency, phase, wavelength, wave velocity. I hope all these things are clear to you. Doubts idre keli. Otherwise this is about mechanical transverse waves. This is where the direction of motion of the wave is perpendicular to the direction of vibration. Such a wave we call it as transverse waves, which are traveling in a medium. They require a material medium to travel, but still we call them as transverse waves because their wave propagation is perpendicular to the direction of the vibration. Is that clear? Okay. So that is about transverse waves. Next, another category of mechanical waves which we need to discuss is longitudinal waves. Okay. Okay, next we shall move on to longitudinal waves. Longitudinal waves. So what do you mean by longitudinal waves? A wave in which particles of the medium oscillate about, a wave in which particles of the medium of the medium oscillate about the direction of propagation of the wave. Direction of propagation of the wave. Example, sound waves. Sound waves is a best example. Sound waves traveling through air. I told you this. What happens, that is, it creates a region of, see, as I speak, it creates low density region here. Low density region, that is called rarefaction. Low density region created is rarefaction. Then it creates a high density of high pressure region, that is called compression. Rarefaction. Then again compression, rarefaction. That is how, due to the pressure difference, sound waves move. Is that clear? Due to the pressure difference, the sound waves move. So these are the best examples. So the sound waves move due to series of alternate rarefaction and compression. Rarefaction is called region of lower density. Region of lower density. Compression is called region of higher density. It is called region of higher density. Okay. So sound waves keep moving as rarefaction and compression. Rarefaction and compression. Hope all these things are clear to you. Okay, so sound waves move traveling through air. So by alternate rarefaction and compression. Rarefaction and compression. Rarefaction and compression. Is that clear? So this is about types of waves. Next we will move on to progressive waves. What are progressive waves? What are the types of progressive waves? We shall move on to that. Progressive waves. So, progressive waves are the one where the disturbance moves continuously through a medium. So, write down progressive waves. A disturbance of a wave, a disturbance which propagates, a disturbance which propagates, continuously in a medium in the same direction, with constant amplitude, is called progressive wave. Okay, so a disturbance which propagates continuously is called progressive waves. Even electromagnetic waves can be included in progressive waves. Why? Because of the oscillation of the electric field vector in one direction, perpendicular to that there will be oscillation of the magnetic field vector, perpendicular to that there will be propagation. So, but it will be continuous, it will be never ending. The oscillations of the electric field, magnetic field vector will continuously give out light. No, such waves are called progressive waves. A disturbance which propagates continuously, progressive. It is only giving out energy and they are moving forward. So it is progressive. So a disturbance which propagates continuously in a medium in the same direction with constant amplitude is called a progressive wave. What are the characteristics of a progressive wave? Of a progressive wave. So we'll write down the points now. What are the characteristics of a progressive wave? What are the characteristics of a progressive wave? First point you write, the wave is propagated through the medium by the repeated and periodic vibrations of the particle. Second one is, there is no bodily movement. Of the medium in the direction of the wave. So you can make out the disturbances are moving, not the medium. Is that clear? The disturbances are moving and not the medium. Then third one is it visible if I write the third point there? Is it visible? Yeah, little bit. One line I can write. Okay. So third point is energy is transferred. From one particle to another by disturbance. So energy is transferred from one particle to another through disturbance or by disturbance. Fourth point, all particles will vibrate with the same amplitude and same frequency. All the particles will have the same frequency throughout and same amplitude. Okay? Same amplitude. Okay, clear? So all the particles will vibrate with the same amplitude and frequency. Is that clear? Same amplitude and frequency. So what happens now is, see, these are the points. Okay, you just think of these points even as this is for your first few exams, okay? First few exam, you just try to read this, okay? And also you should know the characteristics while solving for competitive exams. So the disturbance which propagates continuously in a medium in the same direction with constant amplitude is called progressive wave. Progressive wave. Characteristics of a progressive wave, obviously the wave propagates, wave is propagated through the medium by the repeated and periodic vibrations of the particle, no bodily movement of the particle, energy is transferred from one particle to another by disturbance, all the particle will vibrate with the same amplitude and frequency. Another point is, no two neighboring particles of a medium, no two neighboring particles of a medium, no two neighboring particles of a medium, no two neighboring particles of a medium will have the same phase. Important. Will have the same phase. Vikram sir, Vikram sir. Come on, class. Later. She's okay, so no two neighboring particles of a medium will have the same phase. This is important. ಇಲ್ಲಿ ನೋಡಿ, ಇದು ಇಲ್ಲಿ zero vibration alitre, this should go up low to create a transverse wave. This will have more vibration. So no two neighboring particles, because wave is continuously moving. These progressive waves are never at rest. When they are at rest about the mean position, they will all have the same phase. ಇಲ್ಲಿ no two neighboring particles. Every particle will have different phase. Okay? Every particle will have different phase as it moves. Mean position ಇಲ್ಲೇ ಇದ್ರೆ ಎಲ್ಲದರದ್ದು phase same. ಆಗ ಅಲ್ಲಿ wave nature ಇರುವುದಿಲ್ಲ. No transfer of energy. For the transfer of energy, what should happen? They should vibrate. Okay? So they should vibrate. That is the reason. Is that clear? That is the reason. So no two neighboring particles in the medium will have the same phase. Then sixth point is, no particle, just how I told you, no particle will be in rest. No particle is permanently at rest. They keep vibrating, permanently at rest. To transfer energy, they should keep vibrating. So no particle is permanently at rest in the medium. Then seventh, then the waves can undergo reflection that is these progressive waves, these waves can undergo reflection, refraction, then interference, which you are going to study in second PUC. Okay, interference of two waves. Of course, a part of it is there. Superposition of waves, we will study that also. Interference, diffraction, obviously you are going to study in second PUC. So you know what is diffraction, you know what is reflection. So sound can hit, or any light can hit a place, hit the surface and it can come back. A sound can be echoed, correct? Means it can come back. After reflection it can come back. It can bend also, slightly small, tilted version, slightly manipulated version of sound can be heard. Interference, they can interfere and create a large sound also in a crowd. Diffraction is the one which you may not be aware of right now. Okay? Aware of right now. So these are some of the points or characteristics of a progressive wave. Characteristics of a progressive wave. Okay? So we will move on to wave velocity and all these things now. Okay, next equation of a progressive wave अथवा equation for displacement of a progressive wave. Equation for displacement of a progressive wave. Clear? So now that is given by the equation, general equation. Y is equal to, that is given by the general equation, y is equal to a sin omega t minus kx plus phi, where y is the net displacement. This you have studied in oscillation, previous chapter, correct? A is the amplitude. Omega is angular velocity, frequency, or frequency. K is wave number. Phi is phase difference. Phase difference to be calculated with other wave, general wave. Okay. So phase difference is phi. Think of what is x. so phase difference it is y is equal to a sin omega t minus kx plus phi. Clear? Plus phi. That is also called wave equation. Wave equation plus phi anta baritave. If x where x should be the displacement in x direction at a distance x from the origin. So x is obviously the displacement in x direction from the origin. Okay, so this is for a wave traveling along a positive x-axis, traveling along positive x-axis. Y is equal to a sin omega t minus kx plus phi. Clear? Okay, now this can have different forms also. Before going to the different forms of this, I will define what is wave number. Wave number k is the number of waves passing. So number means, see, if there is a wavelength, particular wavelength lambda to be traveled, okay, this is traveled by one wave, but the distance to be traveled is more than lambda, then I require more number of waves. So if the linear displacement is lambda, angular displacement is 2 pi, then that can give you the count of number of waves traveled. So wave number k is given by the formula 2 pi by lambda. That wave number k can be given by the formula 2 pi by lambda. That is wave number. Obviously, angular speed or angular frequency, angular velocity or frequency, omega is 2 pi nu. So now this can be, if I take the ratio of omega by k, that will give me 2 pi nu by 2 pi by lambda. So omega by k is nu lambda, that is we have seen is velocity. Of the progressive wave. These are the formula, please remember. Okay, please remember for your competitive exams. Try to remember these formulas for competitive exams. Okay, next we shall move on to velocity of a progressive wave. Velocity of a progressive wave is also given by omega by k. Okay, velocity of a progressive wave is also given by omega by k. This we have done it already. Omega by k. Hope all these things are clear to you. Next, we will study about speed of a transverse wave. There is one method to derive speed of a progressive wave. Anyway, I have derived V is equal to omega by k directly. So that is enough. That is enough. Next, we shall just notify this derivation is cancelled. That is by dimensional analysis you can derive. Anyway, that formula is important for your competitive exams. And this year that derivation is cancelled by the method of dimensions. So I will directly give the formula. You take down velocity of a transverse wave on a stretched string. Velocity of a transverse wave on a stretched string is given by V is equal to root of T by mu. Some people write it mu, where T is the tension in the string. Idu string alli velocity. What is the velocity in a stretched string? As I form the disturbances, this is how it is going to move now. So this is tension in the string, and mu is called linear mass density. Mu is called linear mass density. Mu is called linear mass density. Is that clear? Linear mass density andre no. See, density is mass by volume. Linear means line dominates the volume, correct? That means area of the string must be so small that it should be neglected. Area of cross section of the string should be so small that it should be neglected. Okay, so ಏನಾಗುತ್ತೆ ಅದು linear mass density ಅಂದ್ರೆ that is mass per unit length. That is mass of the string divided by length of the string. So more the linear mass density, lesser is the vibration. No, it will take more time. So the velocity of the wave decreases in a stretched string. If the string is light and having lesser linear mass density, then velocity will be obviously more. Correct? Alva, lighter ide adu ashtu waves ತರ ಆಗುವುದಿಲ್ಲ, slow ಆಗ್ತದೆ waves. Then wave velocity will be lesser. So this is a formula for velocity of a stretched string. Okay, next speed of longitudinal waves. I'll write it. I hope all of you have written this down. Okay. So, speed of longitudinal wave. Speed of longitudinal waves, or best example for a longitudinal wave is sound traveling in air. So speed of sound I can relate. Okay, now see, sound travels due to the change in pressure. I told you already. Due to change in pressure, sound travels. Agree? So that change in pressure is due to the change in volume of the air molecules. So change in pressure is due to the change in volume of the, as the pressure changes, the volume of the air molecules also changes. Some part will be expanded, some part will be compressed. So rarefaction, compression, rarefaction, compression. That is how the sound is going to travel. That is how the sound is going to travel. Correct. Now, write down. When a longitudinal wave propagates through a medium, obviously the particles vibrate forward and backward, correct? Longitudinal waves propagate through a medium, particles of the medium oscillate forward and backward due to the change in the direction of propagation, So the bulk modulus of the medium is defined as change in pressure divided by delta V by V. This you have learnt in solids, correct? Mechanical property of solids. So here change in pressure produces a volume strain, obviously. Then by methods of dimension, I don't derive this, by methods of dimensions we get V is equal to root bulk modulus by rho, where rho is density of the medium. So this is a velocity of longitudinal waves in a medium, where B is its bulk modulus, rho is density of the medium. Here the change in pressure delta P produces volume strain delta V by V. So then we bulk modulus we have to substitute dimensionally. ಮಾಡೋದಾದ್ರೆ ಮಾಡ್ಬೋದು, ಟೈಮ್ ನೋಡಿ ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್ಗೆ ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು ಫಸ್ಟ್. ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್ ಮತ್ತೆ ಚೇಂಜ್ ಇನ್ ಪ್ರೆಷರ್ ಮಾಡಿಕೊಂಡು ಇಲ್ಲಿ volume ಇದೆ, then you can substitute. So directly you have to substitute, that's all, dimensionally. So this is not required, you just try to remember this formula. Okay, so speed of the sound in a solid bar, speed of the sound solid bar alladhe longitudinal strain matra alla, in a solid bar, metal bar, then it will possess Young's modulus, then it is Y by rho. Ishte idu formula ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ. Actually, this can be derived using methods of dimensions, but anyway, this year exam they won't ask any derivations. From dimensional analysis derivation they don't ask. From this chapter, there are some other derivations which I am going to do. So just remember, this is the velocity of the longitudinal wave. Next, in the next class, probably we shall study velocity or speed of the sound in a gas, which is the derivation, which is the actual derivation you need to learn. That we will study in next class. Okay. So this much notes you try to have along with the printed notes that have been posted in the group. You try to have whatever I've written on the board. Okay, that will help you to solve problems. Okay, so I'll conclude the class for today. We'll meet up next class. Okay, thank you.